So now right click, go to callbacks, callback menu. Okay. Now in order to generate a sine signal, what parameters we required? We required a frequency, we required a time period. Am I right? So I'm going to take frequency as f equal to, I'm defining 50 hertz. I'm going to generate a signal frequency 50 hertz. And time period I'm going to take as starting from 0, the variation of 0.001 till 1. Okay. Signaling variable I'm giving SIG. SIG for signal. Okay. No, you can write whatever variable you want. For my understanding, I'm writing signal SIG. So I'm gonna write with a magnitude of 10. I'm assuming the magnitude of the signal as 10. 10 multiplied by sine 2 pi f p. Okay. So now my signal is stored in SIG. Now I want to plot this. How you will write usually? Plot. Normally MATLAB programming is how you will be writing this. Plot t comma SIG. X-axis is t, y-axis is your signal strength. So you can, apart from that, here what you are supposed to add is where you are going to display that. You are going to display using this axis. What is the name of that tag? app.ui axis. So I suppose to write here plot app dot, automatically it is showing UI axis. I'm just pressing enter, comma, my x-axis is t, automatically it is showing t, I'm just pressing enter, comma, y-axis is SIG. Yes. So that's it. Program is over. I'm done with the program. Okay, so yeah, frequency I defined, time period I defined, and the signal strength I defined it here, it has 10. And I'm just going to plot that. Usually plot, how we are going to plot mean plot x-axis comma y-axis we do. But here I'm going to display the signal using UI axis. So I'm gonna use that UI axis tag name here. So that automatically signal will go and store there. I mean displayed there. I'm just running the program. See. So I'm just gonna start it. Yeah. I generated a sinusoidal signal, you could see here. Then later on, the signal is displayed. So from this experiment, what you're supposed to learn is how we can display a signal. And you might have come across some signal processing techniques under like how we can perform filtering, how we can extract some features from the signal. Once the signal is having a noise, you can display a signal, original signal with noise, and then you can apply some noise removal techniques. So after noise removal techniques, you can filtered out signal can be displayed. All those things part according to your requirement you can implement. So this is what you are supposed to learn from this experiment. So apart from this, for suppose I want to see the maximum amplitude of the signal. So for the same program, I'm just going to add that field also. So I'm going to add now, edit here. Here I'm giving the name as max. Capital M I'm typing. So whatever name you are giving, you should remember. If you're having a doubt, you could see here the tag name. app.max edit field, capital M. Okay. So what I'm going to do means, again going to call back. I'm going to display the maximum amplitude of the signal. So what I supposed to do, app dot. So by default it is showing max edit field, and then value V caps at equal to what I supposed to write here? Any guess? What I supposed to write? Max of straight away I can write max of SIG because my signal is in SIG right away. Or else you can store this max of SIG value in some variable. That variable you can pass on to this function. So anything can be done. So why to write unnecessarily one more line? Straight away I'm writing max of SIG.